So we're now going to have a look at another question. This one comes from the 2022 HSC Standard 2 Maths paper. This is question 20 from the paper. So this is a graph theory style question. So we're given a table. This table shows the distances between particular towns. And we are given a little diagram in part A, and part B in fact, but we'll just draw the diagram for part A first, showing these towns. So we have S here, we have Y here, we have B here, we have C here, and we have M over here. And the question says, using the vertices given, draw a weighted network diagram. Okay, so we have to connect the dots that we know can be connected. So from our table, if we look at S has two connections. It goes to Y and it goes to B. So we have S goes to Y and S goes to B. The distance from S to Y we're told is 280. The distance from S to B we're told is 275. We now look at C. C has two connections. One goes to Y and one goes to B. So we have one goes to Y and it is 60, and one goes to B and it is 150. We then look at Y. It has three connections, one to S, one to C, and one to M. So we've already got the one to S, we've already got the one to C. Now we need an extra one for M, and it is 530. We now look at B. B has three connections, one to S, one to C, and one to M. Well, we already have the S and C connections, so we're just going to be connecting this one to M. This is 790. And then we look at M. M has two, one to Y and one to B. We already have those. Consequently, this is the correct network diagram. So this is our correctly drawn network diagram. This is worth 2 marks. You will get 1 mark if you draw a network diagram that is not completely correct but is close. So 1 mark for something close, 2 marks for exactly the correct network diagram. Now for part B of this question, we're told a tourist wishes to visit each town, draw the minimum spanning tree which will allow for this, and determine its length. So this question, you can do minimum spanning trees quite a few ways. There's formal methods for doing these, and we're going to do one of the formal minimum spanning tree methods. Or you can just guess and check, right? You can just try different paths, find a whole bunch of likely different paths, pick the shortest one, and then hope that that's the minimum. That will often work in these questions. When the questions are quite simple, you can often guess and check. If you're getting a computer to find minimum spanning paths in simple problems, that's often what the computer will do. It will just look at all the possible ones and then find the shortest, because that's really easy, right? But we can actually do a shortest path algorithm. So we're going to do a standard shortest path algorithm. This is going to start us at a particular point. From that point, we will pick the shortest path leading to a different node. And then from all of the collections of possible nodes, we will continue to pick the shortest paths to another node, assuming that it does not close the path. So I'm going to do this in purple. I'm going to start at S. I can either go down to B, which is 275, or up to Y, which is 280. I'm going to pick the shorter of those two. So now we have SB. Now I can either go from S to Y, which is 280, from B to C, which is 150, or from B to M, which is 790. The shortest of those is B to C. I can then go from S to Y, which is 280, from C to Y, which is 60, or from B to M, which is 790. The shortest of those is C to Y, which will take us up to here. We can no longer travel along this 280 because it would close our little path. So this is no longer possible. So now we can either go from B to M, which is 790, or from Y to M, which is 530. The shorter of those is from Y to M. And this is our minimum spanning tree. So in this case, the min spanning tree that we found was S to B to C to Y to M. So we found this, but we also need to find the length. The length of the minimum spanning tree is the sum of all of the paths. So 275 plus 150 plus 60 plus 530. So when we add these all together, this gives us 1015, and this is in kilometers. So the marking here is reasonably generous for these types of questions. You get 1 mark for drawing a spanning tree. Some kind of tree that spans the graph will get you 1 mark. To get a second mark, you have to have a minimum spanning tree. So you have to have a spanning tree, it has to be a minimum, and then to get the third mark, you have to have the length of the minimum spanning tree, and that length must be correct. So this question was worth 5 marks. It's a fair few marks. They're reasonably simple to do if you've memorized the algorithms for spanning trees, and if you've practiced a few times converting tables into graph diagrams, so into network diagrams, that is.